Hello everyone and welcome to another lesson. In today's lesson, we will be talking about hypothesis testing for one sample test, and this is chapter 9. So in today's lesson, we'll be talking about basic principles of hypothesis testing to test mean or proportion, assumptions of each hypothesis testing, avoid the pitfalls involved in hypothesis testing, and finally, calculating and interpreting the power of hypothesis test. So today we have two areas that we will be talking about. First, we have the lesson structure, right? And then we have an additional note on power of a hypothesis test. So let's have a look at this lesson structure. So in our lesson structure, we'll be talking about four areas. What is a hypothesis? Errors in hypothesis testing, hypothesis tests for the mean, and finally, hypothesis test for proportions. Okay, so before we start off, I would like to remind you to check the YouTube description down below, where I have included timestamps so that you can easily navigate through this video, and I have also included external links for further reference. So now let's have a look at the first section in our lesson structure, which is what is a hypothesis. So before we get into this, I would like to mention that I have included a video here which explains about hypothesis and hypothesis testing. Please do go ahead and watch this video. It will provide you with more insight. So the first question we have is, what is a hypothesis? A hypothesis is basically a claim or some kind of an assertion about the population parameter. So what are our population parameters? For example, we can take population mean, population proportion, likewise. So we are making a claim about this particular population parameter. So this is what you call a hypothesis. So for example, if you take population mean, this could be a hypothesis. What does it say? It says the mean monthly cell phone bill in this city is mu equals $42. That is a hypothesis because you're making a claim about the population mean. And what is the population mean here? The population mean of monthly cell phone bills. So if you consider population proportion, this could be another example of a hypothesis. The proportion of adults in this city with cell phones is pi equals 0.68. So a hypothesis, remember, is a claim about a population parameter. So continuing on, like I said before, it is a claim or an assertion to be tested. So I have given another example here. What is very important to keep in mind is this fact, that a hypothesis is a claim about the population parameter and not about a sample statistic. So keep that in mind. That is, although this is very basic, it is very important. So I have used this H0 here. Don't think about it right now. In the next slide, I will explain it. But what is important is this mu. Mu is population mean. So what we are talking about is the population parameter and not the sample statistic. So x bar is your sample mean. That is not what we are talking about under hypothesis. So what was that H0? That is called a null hypothesis. So you begin with the assumption that the null hypothesis is true. And the null hypothesis, what is important is that it always contains the equal sign. If you noticed in our previous example, we had the equal sign. And for that, we call it the null hypothesis. So like I said, it begins with the assumption that the null hypothesis is true. And it always contains the equal sign. This is also a very important point here. And then it may or may not be rejected. So you start off with the assumption that H0 is true, and it might be or might not be rejected as you do the hypothesis testing. So if you have a null hypothesis like this, where you assume that the null hypothesis is true and you test this, you have another hypothesis called alternative hypothesis, where you use the symbol H1. For your null hypothesis, you used H0. So obviously, your alternative hypothesis would be the opposite of the null hypothesis. So in our previous example, we considered the average diameter of a manufactured bolt is not equal to 30 millimeters would be your alternative hypothesis. Your null hypothesis would be the average diameter of a manufactured bolt is 30 millimeters. That is your null. So when you say not equal to, you know, okay, this is your alternative hypothesis. Because remember, in your null hypothesis, it always contains the equal sign. When I say equal, don't confuse yourself with only the equal sign, because the null hypothesis can also include greater than or equal sign or less than or equal sign. Because notice in my phrase I use greater than or equal sign or less than or equal sign. So then accordingly, your alternative hypothesis would be less than or greater than accordingly. So the alternative hypothesis, it challenges the status quo because the null hypothesis was the status quo. So it may or may not be proven. Remember, the null alternative hypothesis does not contain the equal sign. And what is important is the last point. It is generally the hypothesis that the researcher is trying to prove. Right, so let's have a look at how this process works. So you make a claim. The population mean age is 50. So you write it down. Okay, the population mean age is 50. So my null hypothesis is mu equals to 50. Remember, the null hypothesis contains the equal sign. Therefore, the alternative hypothesis would be mu not equal to 50. So why did I consider mu? Because I'm talking about the population mean. So that means I'm talking about hypothesis testing. I'm making a claim here, which is a hypothesis. So I write down my null hypothesis and my alternative hypothesis. Now what do? So now you can take a sample from your population and find the sample mean. So you have your population from which you can derive a particular sample, and from that, let's assume that your sample mean was 20. Now 20 is significantly lower than the mean population of 50. What does this tell us? So if the null hypothesis, what was the null hypothesis? Mu equals 50. If that was true, the probability of getting such a different sample mean of 20 would be very small. The probability of you getting 20 would be very small. So you reject the null hypothesis. So in other words, what I'm saying is, getting a sample mean of 20 is so unlikely, because if the population mean was 50, you can conclude that the population must not be 50. Because if you get a sample mean of 20, whereas you claim that the population mean is 50, then because the chances of you getting 20 is very less. So that means your claim or your null hypothesis should be rejected, because it cannot be, right? So that is what I have mentioned here. But let's have a look at this graphically. So what I'm talking about is, I take the sampling distribution of your sample statistic x bar, and here you have your population mean equal to 50. So that is your null hypothesis if H0 is true. And here you would have 20, which is your sample statistic. So you can see here that when you draw this curve, the normal distribution, the probability of you getting 20 is very small, right, for a sample. So that is why I said getting a sample mean of 20 is very unlikely if the population mean was 50. So then you can say, you can conclude that your population mean actually can't be 50, right? So I would like you to pause this video, go back and see what I just said right now, because it might be a little bit confusing, but the moment you understand this, it will click to you that, because this is a very important concept to understand, although it is very simple. What is this H naught? What is this alternative hypothesis? Why are we rejecting this H naught? Why are we considering this alternative hypothesis? All of these facts you have to fully grasp in order to understand the concept of hypothesis testing. So that is why I said go back in the video and watch this again and listen carefully to what I say as to why I said in conclusion that the population mean cannot be 50. But of course, this is not a good way of, coming about to a particular conclusion. So you need a statistical approach for this. So that is why you have this test statistic and something called the critical values. So what we are saying is, if the sample mean is close to the population mean, the null hypothesis is not rejected. But if the sample mean is far from the population mean, the null hypothesis is rejected. So this word far, it is a very vague term. How do you define this, quantitatively? So how far is far enough to reject H naught? So that is where this critical value of a test statistic comes into play. So let's have a look at this graphically. What are these critical values? So you have your sampling distribution of a test statistic, right? So I would remind you to go and watch chapter 7 about sampling distributions if you have forgotten this, and I will post a link above to this. So you have your sampling distribution. These two stars here would be your critical values, such that the shaded area would be your region of rejection and the non-shaded area would be your region of non-rejection, where too far away from mean of sampling distribution would be given by these shaded areas. So our task is to come up with these critical values. You have to give a quantitative value to this vague term of far away, right? Too far away. So I am assigning a quantitative value, and that is known as critical values. So in our next section, let's have a look at errors in hypothesis testing. So before we move on, I would like to mention that I have included another video which explains the types of errors. Do watch this video. So there are two main types of errors when it comes to hypothesis testing. So we name it as type 1 error and type 2 error. Now type 1 error is considered a very serious type of error. So what is this? Type 1 error is where you reject your H naught or your null hypothesis when it is considered true. So when you're rejecting a true null hypothesis, that is considered as a type 1 error, which is a serious type of error. So the probability of a type 1 error is alpha, and you call this the level of significance of the test, and that is set by the researcher in advance. Your type 2 error is when you fail to reject a false H naught or a null hypothesis, and the probability of a type 2 error is beta. So let's have a look at this in table format. When you're rejecting your H naught, when it is considered true, that is when you call it a type 1 error. That is, you're rejecting a true null hypothesis. And when you're not rejecting your null hypothesis when it is false, is called the type 2 error. And the probability of that occurring is beta. So 1 minus alpha and 1 minus beta is the corresponding probabilities when you do not have the error. Right, so let's move on. So the confidence coefficient is given by 1 minus alpha is the probability of not rejecting H0 when it is true, and the confidence level of a hypothesis test is given by 1 minus alpha times 100%. And the power of a statistical test, which is given by 1 minus beta, is the probability of rejecting H0 when it is false. So this power of a statistical test and all of this, I will talk about this after I'm done with the lesson structure in an additional note. So next, let's have a look at the relationship between these two errors. The important thing to keep in mind is these two errors cannot happen at the same time. So a type 1 error can only occur if H0 is true. Type 2 can occur only if H0 is false. So that's what we talked about. Type 1 error is where you reject your H0 when your H0 is true. Type 2 error is where you do not reject your H0 when H0 is false. So these two cannot occur at the same time. But if your type 1 error probability increases, the important and key thing to keep in mind is your type 2 error probability, beta, decreases. So if you keep everything else equal, what are the factors that would affect your type 2 error? So type 2 error probability is beta. What are the factors that would affect this? So if you keep everything else constant, your beta or your probability of type 2 error occurring would increase when the difference between hypothesized parameter and its true value decreases. So when the difference between your hypothesized parameter and its true value decreases, that would lead to an increase in your beta. Also, your beta increases when your alpha decreases. Now, what is alpha? Alpha is the probability of type 1 error. That is what we talked about before. Again, your beta increases when your sigma increases, and finally, your beta increases when your sample size decreases. So, let's have a look at this graphically, the level of significance and the rejection region. So if you consider the example of the diameter of that bolt, where the population mean of the diameter of that bolt is 30, your null hypothesis is mu equals 30 and your alternative hypothesis mu not equal to 30. You consider your level of significance as alpha, and then when you draw the graph, you have 30 as your population mean, and you have your critical values, some value, and then you have your rejection region, and the rejection region probabilities are alpha divided by 2 respectively. So this is called a two-tailed test because there's a rejection region in both tails, since if you look at H1 or your alternative hypothesis, it says mu is not equal to 30. Now what does that mean? If mu is not equal to 30, there can be only two options. Either mu is less than 30 or mu can be greater than 30. So from that you understand, when you look at your alternative hypothesis, you understand, okay, this is a two-tailed test because it says mu is not equal to 30, then you understand it can have either mu is less than 30 or mu is greater than 30. From that, you know this is a two-tailed test. Right. So now let's have a look at the two important sections. And the first important section is the hypothesis test for the mean. So like before, I have included another video here which explains hypothesis test for mean. I implore you to watch this video so that you will get a better understanding as well. So let's move on. So when it comes to hypothesis tests for the mean, there are two aspects that we look at. and that we will discuss under this lesson. The first one is when your population standard deviation is known. For that we use the Z test. And the second one is when your sigma is unknown. For that we use the T test. So these are the two angles and the two aspects that we will be discussing under hypothesis test for mean. So let's first have a look at the first one, which is when your sigma or your population standard deviation is known. So you use the Z test. So the hypothesis test for the mean when sigma is known. So in this case, what we talked about was sigma unknown and sigma known case. So we are talking about the sigma known case now. So the test statistic is Z, and that is given by this particular equation. Your sample statistic for mean, which is x bar, minus your population parameter for mean, which is mu, divided by your sigma, population standard deviation, which is known, divided by your sample size, root of simple n. So first, let's have a look at this critical value approach to testing. Now remember, we talked about something called the critical value. Now we are dwelling in deeper to how you find this particular critical value. So for a two-tailed test for the mean when sigma is known, what you do is you first convert your sample statistic x bar to your test statistic, which is your Z stat, because you know your sigma. And then from that you determine the critical Z values for a specified level of significance alpha. So how do you determine your critical value? You convert your sample statistic, which is in this case x bar, because you're talking about mean, to your test statistic, Z stat. Why are you considering Z stat? Because you know your sigma or your population standard deviation is given. So from that Z value, you determine the critical Z values. So that is these critical values are your Z values for a specified level of alpha. So your level of significance should be given alpha, whether it's 0.05, 0.025, something should be given. And then you have a decision rule. So if the test statistic, which is your Z stat, falls in that rejection region which we talked about, then you reject your null hypothesis, which is H0. Otherwise, that is, if it doesn't fall in the rejection region, you do not reject your H0. So let's have a look at this graphically, what this looks like, the two-tailed test. So there are two cutoff values. That is important because it's a two-tailed test. There are two cutoff values or critical values. And those two values define your region of rejection. So you have your sampling distribution for your sample statistic mean, and your population mean is 30. So you're testing for this scenario where your null hypothesis is your population mean equal to 30, and your alternative hypothesis is where your population mean is not equal to 30. So accordingly, you have the negative value of your Z stat and your positive value. So these values are determined according to the given level of significance. So when you're given the level of significance alpha, you divide it by 2 because you're talking about the two-tailed test, and you're dividing it by 2 because it is symmetric. So how do you know whether it's a two-tailed test? Let me remind you again. You look at the alternative hypothesis, you see that mu is, or your population parameter, is not equal to this particular value. Therefore, it can either be less than this particular value or mu can be greater than this particular value. From that, you identify, okay, this is a two-tailed test. So now let's have a look at the 6 steps in hypothesis testing, right? So that is very important, these steps. So the first step is you state your null hypothesis and the alternative hypothesis. When you're given the problem for hypothesis testing, you have to first figure out what is your null hypothesis and what is your alternative hypothesis. And then you're given the level of significance alpha and the sample size. You write that down as well. You determine the appropriate test statistic and the sampling distribution. How do you determine the test statistic? So if you're given a question about hypothesis testing for mean, you read the question and see whether your population standard deviation is given. If it is given, you use the Z test statistic. If it is not given, you go for the T test statistic, and accordingly you have your sampling distribution either for mean or proportion. That is level step 3. Step 4 is where you determine the critical values that divide the rejection and non-rejection regions. So now you calculate your test statistic from which you obtain your critical values. Why are these critical values important? Because it helps us to identify the rejection and the non-rejection regions. Step 4. You collect the data and compute the value for the test statistic. Step 6. This is where you make the conclusion. So if your test statistic falls in the non-rejection region, you don't reject H0. But if your test statistic falls into the rejection region, you reject your H0. So then you give the conclusion in the context of the given problem. So let's have a look at an example now. So we are looking at the same example which we looked at before as well. So you're testing the claim that the true mean diameter of a manufactured bolt is 30 millimeters. Look at the claim, the true mean diameter. So you're testing the mean. And this is the hypothesis of a manufactured bolt is 30 millimeters. And you're given the population standard deviation. So when you read this question, you know, okay, you're given the population standard deviation and you're talking about testing a claim for population mean. So what are you doing? You're testing for your hypothesis testing is for the population mean when the population standard deviation is given. So your test statistic would be your Z statistic. So what is the first step? The first step is to state your null hypothesis and the alternative hypothesis. So the null hypothesis, remember, always has the equal sign. So in this case, your null hypothesis is your population mean, mu. Remember, hypothesis is always for the population parameter. So in this case, it's population mean equals to 30 and your alternative hypothesis is not equal to 30. So this is the two-tailed test. How did you identify that? You look at the alternative hypothesis, you see that it is not equal to some value. So that means it's either less than this particular value or greater than this particular value. In that case, you have two-tailed test. So the second step is what? The second step is you're given the level of, you write down the level of significance and the sample size. So in this particular question, ideally the level of significance and sample size should be given. So let's suppose that your level of significance is 0.05 and the sample size is 100. What is the third step? You have to determine the appropriate test statistic. So in this case, you're given the population standard deviation. So you know that you will be using the Z test. The fifth step is you collect the data and you compute the test statistic. Right. So for given level of alpha 0.05, your critical values are plus or minus 1.96. You can obtain this from the table, and accordingly, your test statistic is minus 2.0. So how did you calculate that? So you know your equation for Z stat, which is x bar minus mu over sigma over root 10. You simply substitute the values. Here it should be x bar. X bar is your sample statistic for mean 29.84 minus population mean is 30 divided by sigma is given 0.8 divided by sample size 100. So in this question, let me repeat again, you should be given the level of significance alpha and the sample sizes well. So then let's have a look at this particular question, what it looks like graphically, because we need to identify whether the particular test statistic is in the given region, or what is that region? The rejection region. So here you have your rejection regions. Your critical values are minus 1.96 plus 1.96. Accordingly, the shaded area is your rejection region and the non-shaded area would be your non-rejection region. So if your Z stat is less than minus 1.96 or greater than plus 1.96, you reject your H0, right? If not, you do not reject your H0. So where does your Z stat stand? Well, it is somewhere here because the value is minus 2. That is the value you got for your Z stat. That is less than 1.96, minus 1.96. So since the test statistic is less than this critical value, this stands in the rejection region. So what do? Therefore, you reject your H0, right? So how do you interpret this particular result? Now you obtain all of this and your minus 2 is your Z stat. So you reject your null hypothesis and you have to write the conclusion. And you conclude there is sufficient evidence that the mean diameter of a manufactured bolt is not equal to 30 millimeters. So see, you have to write the conclusion with the given context. Your problem, you look at the problem and accordingly you have the solution here, and based on that you write your conclusion. So this is one approach for your hypothesis testing, which is where you use the critical value approach. Now there's another approach called p-value approach to testing. So what is this? The p-value is basically the probability of obtaining a test statistic equal to or more extreme than the observed sample value given your H0 is true. Basically, the p-value is a probability value, is also called the observed level of significance. Now the important factor here is H0 or your null hypothesis is rejected if the p-value is less than alpha. That is what you have to keep in mind. So your H0 is rejected if the p-value is less than your given level of significance alpha. So in summary, what I want you to remember is if your p-value is less than alpha, you reject H0. If your p-value is greater than or equal to alpha, you do not reject H0. To simply remember this, you can use this particular quote: if the p-value is low, then H0 must go, because it rhymes nicely there. So what are the steps involved in this p-value approach to hypothesis testing? Now remember, we are talking about hypothesis testing for the population parameter mean, under which you had two sections where you looked at the population standard deviation is known and the population standard deviation is unknown. Now we are talking about the population standard deviation is known case, where you use the Z test statistic. So when you're testing for this, you have two approaches. One is the critical value approach, which we talked about, and now we are talking about the p-value approach. So the 5 steps involved here is, first again you state your null hypothesis and the alternative hypothesis, just like in the critical value approach, and you'll be given your level of significance and the sample size. Write that down. Third one, you determine the appropriate test statistic and the sampling distribution. Now you collect your data and you compute your test statistic, and finally you make a conclusion, very similar to the critical value approach. But there is a small difference when you look at it graphically. But let's first have a look at an example. We will talk about the same example, because then it would be easy, about the manufactured bolt being 30 millimeters, the mean diameter. So first you state your null hypothesis and alternative hypothesis, just like before, your level of significance and your sample size. You compute your sample test statistic for mean, and so you get your test statistic, which is Z stat, as minus 2. Now in step 4, you calculate the p-value. So how do you do that? You ask yourself this question: how likely is it to get the Z stat, which is minus 2, if H0 is true? So let's have a look at this graphically. So you have your standard normal distribution, where your mean is 0, and you have your shaded area, which is your rejection region, reject H0, which is your critical value, minus 2. Now what you do is, how you calculate your p-value is, you go to your table and see where you get minus 2, right? And you will get the answer as 0.0228. When you go and check your standardized normal distribution table, you check where Z is less than minus 2. And when you check the table, the value you will get is this value, 0.0228. So now how do you calculate your p-value? Since this is a two-tailed test, what you do is you add these two values, or you multiply this by 2. Since this is a two-tailed test. So accordingly, you get the p-value as 0.0456. Now, how do you know whether to reject your H0 or not? You compare your p-value with the level of significance. Now, what was your level of significance? 0.05. So now, is this p-value greater than or less than 0.05? It is less than 0.05. So if your p-value is less than 0.05, you reject your H0. Remember, if the p-value is low, then H0 must go. You can keep that in mind as well if you forget this. Basically, your p-value is less than alpha, so you reject your H0. This is not the end of the answer. You have to write the conclusion as well, which is called the managerial conclusion in the context of the situation. So what do you write? There is sufficient evidence to conclude that the average diameter of a manufactured bolt is not equal to 30 millimeters. Right. So now let's have a look at the connection between two-tailed test and the confidence interval. We talked about confidence intervals in our previous chapter, chapter 8. I will have a link in this particular video above. So for your sample statistic mean of 29.84 and your population standard deviation 0.8, sample size of 100, the 95% confidence interval, you write it down as your sample statistic plus or minus your critical value, in this case was 1.96, times 0.8 divided by root of sample size. So that is given by this. So here I have separated the plus or minus signs to make it a little bit easier. If you can't remember this, please go back and watch chapter 8 on confidence intervals. So accordingly, you get your population mean mu in between these two values. How do you obtain this value? By solving this equation, this expression. And how do you obtain this value? By solving this expression. So accordingly, since this interval does not contain the hypothesized mean of 30, we reject the null hypothesis. So you see, 30 is not in this particular interval. So you can reject the null hypothesis at this level of significance. Now remember, if this alpha changes, your conclusions may or may not change. So your given level of significance is very important for your conclusion. Right, so what did we talk about? We talked about mainly hypothesis testing for the population mean when your population standard deviation is known. Now let's have a look at when your population standard deviation is unknown. So in this case, what is the test statistic that we will be using? We'll be using the t-test statistic, where you use the sample standard deviation. Because your population standard deviation is not known, you use your sample standard deviation. So like I said before, you'll be using your t statistic or your t distribution in the case of sigma unknown, and the expression for that is given by x bar minus mu divided by s over root n. So in the previous case, we used sigma because your population standard deviation is given in the previous case. In this case, you don't know your population standard deviation, so you substitute it by your sample standard deviation s. Hence why you are using your t distribution. So let's have a look at an example. So you're told the average cost of a hotel room in New York is said to be $168 per night. To determine if this is true, a random sample of 25 hotels is taken and resulted in this should be x bar of $172 and an s of $15.4. Test for the appropriate hypothesis at alpha equals 0.05. Right, so you're given a lot of information. But first you need to identify what you're asked to test. That is the key statement here. So They're saying the average cost, okay, they're talking about mean of a hotel room in New York is said to be $168 per night. So they're saying your population mean is equal to $168. So what is this then? This would be your null hypothesis, the statement that I've underlined. Accordingly, your alternative hypothesis would be your mean is not equal to $168. Then you know that this is a two-tailed test because your alternative hypothesis is not equal to some value, which is in this case is $168. And you're given the sample size 25 and you're told your x bar, this should be x bar, that is given as 172 and your sample standard deviation is 15.4. So you know that since your population standard deviation is not given, you use the t-test statistic and you're given the level of significance of 0.05. All of this information you have to quickly identify because that would help you in your workings. So let's have a look at the workings now. And important thing to keep in mind, you have to assume that your population distribution is normally distributed. So if it's not given in the question, make sure before you write the answer, on top you write down, assume that the population distribution is normally distributed, because if not, you cannot solve this in this particular manner. So what do you do first? You write down your null hypothesis and your alternative hypothesis. So we know we are talking about the population parameter mu, and the claim was that it is equal to 168. So that is your H0. H1, mu is not equal to 168. Since this is not equal to 168, either mu can be less than 168 or mu can be greater than 168. That is why you have a two-tailed test. And you write down your level of significance and your sample size 25. Remember, in the t-test statistic, we talk about something called the degrees of freedom, which is n-1. So in that case, it's 24. And your sigma is unknown. That is why you use your t-test statistic. And your critical value, you go to your t-distribution table and you check the degrees of freedom is 24 and the level of significance is 0.025. Why is it 0.025? Because we are talking about two-tailed test. So this alpha is divided by 2. That is how you get 0.025. And the resulting value would be plus or minus 2.0639. Now all of this you have to write down because it is important. Then you draw your particular graph because it's easier for the eye when you look at this. So you have alpha divided by 2. This is your shaded region. And you have calculated your t-test statistic, which is 2.0639. And this would be your rejecting H0 region on either side, and in the middle would be your do not reject H0. So now you calculate your t-stat. Now how do you calculate that? You substitute the values to this equation and you get 1.46. Now where is 1.46? Obviously it's in between these two values, minus 0.2 and plus 0.2. So since 1.46 is in between these two values, your conclusion would be you do not reject H0. Now that is not enough. You have to also mention that it is insufficient. There is insufficient evidence that the true mean cost is different from $168 because you do not reject H0. Right. So what is the confidence interval for this? At 95%. 95% confidence interval. So you have your x bar, s and n. So 95 confidence interval is given by this. So you have a sample statistic. So plus or minus, I have separated the two. Your critical value times your sample standard deviation divided by your sample size, the square root of your sample size. And you get your mu confidence interval as these two values. So since this interval contains the population mean or the hypothesized mean of 168, since 168 is in between these two values, we do not reject the null hypothesis at alpha equals 0.05. So this is the confidence interval approach to deciding whether you reject or do not reject your null hypothesis. So all this time we were talking about two-tailed test. Now what does a one-tailed test look like? So what is this one-tailed test? So if you're given your null hypothesis as mu is greater than or equal to 3 and your alternative hypothesis mu is less than 3, then this would be a lower tail test. So when you look at this alternative hypothesis, you see that mu is less than 3. So it's towards the left hand side, which is the lower end. So that is why it's a lower tail test. And then if your alternative hypothesis mu is greater than 3, it's on the right hand side or the upper end of the tail. So that is why it's an upper tail test. Both of these are examples of one tail test. So let's have a look at this lower tail test, what it looks like graphically. So you have your lower tail test. There's only one critical value because it's a one tail test. In your two tail test, you had two critical values. The same value plus or minus because it's symmetric. In this case, it's a one tail. So you have only one critical value. So we are still talking about the mean. So I'm drawing for the sample statistic mean, the sampling distribution. And here you have alpha, which is your level of significance. Now remember, since this is a one tail test, you do not divide this by 2. You only divide it by 2 where you have two tail test under this case of hypothesis testing for population mean. So it's either Z alpha or T alpha, and it's a negative value because it's to the left of 0. It's Z alpha if your population standard deviation is given. It's T alpha if your population standard deviation is not given. And that would be your critical value. Right, so that is your lower tail test. Now let's have a look at the upper tail test. Same thing applies. There's only one critical value. Again, it's alpha, not alpha divided by 2. So your critical value would be Z alpha or T alpha, and it would be a positive value because it's to the right of 0. So let's have a look at an example now. We'll have a look at an example of an upper tail test. So you're told a phone industry manager thinks that the customer monthly cell phone bills have increased and now average over $52 per month. The company wishes to test this claim. So you're given, within brackets, assume a normal population. So when you're reading this particular question, look at what they're asking for. They are giving a claim. So you know, okay, this comes under the hypothesis testing problems set. So under hypothesis testing, up to now we have talked about only hypothesis testing for mean. So check whether they have talked about that. Yes, they're talking about, and now average is over $52 per month. They're talking about the average. Okay, so that is mean. Now look at this this particular term, over $52 per month. That means this is actually giving you your H1. Why is that? Because in your H0, you always have to have the equal sign. And they're claiming for, remember, the alternative hypothesis is what the researcher is always testing for. If you do not remember that, go back in the video and check it out. I mentioned that when we are talking about alternative hypothesis and null hypothesis. The alternative hypothesis is what the researcher always tries to test. So in this case, when you are given and now average is over $52, this is your H1 or your alternative hypothesis. Accordingly, your H0 or your null hypothesis would be your average less than or equal to $52 per month. So let's have a look at how you write that down. So the solution, hypothesis test, your H0 is mu less than or equal to 52. Your H1 is mu greater than 52. Remember, in the null hypothesis, you have to have the equal sign. That is why this here is your alternative hypothesis, and anyway, any researcher would try to test the claim of an alternative hypothesis. So how do you go about solving this? Well, you're not given your population standard deviation, so you know you will have to use the t-test statistic, and accordingly, let's calculate that. So your alpha is 0.1 and your sample size is 25. So you have to find the rejection region. You reject your H0 here, right? So what do you mean? What do I mean by here? You have to calculate that critical value. So that is 1.318, right? So you reject H0 if your t statistic is greater than 1.318. How did I obtain this 1.318? You go to your t table and you know your degrees of freedom would be 24 since your sample size is 25 and your level of significance is 0.1. So go to your t table and check for degrees of freedom 24 and level of significance of 0.1. You will see that the value is 1.318. So this is your critical value. If the calculated t-test statistic is greater than this particular value, or in this case, if it's here in the shaded region, you reject your H0. If it is less than this particular value or somewhere here, you do not reject your H0. So let's calculate that particular value. And when you calculate your t-test statistic, you would get 0.55. By substituting the values, you would get 0.55. So where is 0.55 in our graph? So in our graph, 0.55 would be here. So which means your t-test statistic is less than that critical value. So you do not reject your H0 because your t-stat is less than 1.318. All of this you have to write, keep in mind, when you're answering the question, you have to write all of this. And then you say there is insufficient evidence that the mean bill is over $52. You do not simply end at this point where you say you do not reject H0 since blah blah blah, but you have to also write this particular conclusion because this is what the particular manager or a store owner or someone who requires this information would understand. Someone who doesn't know statistics would understand only this statement, not this. So you have to write this last statement as well. Right, so the last section under this is where we look at the example from the p-value approach. So in the p-value approach, you calculate the p-value and you compare it to your level of significance. So this is the graph we had. You calculated your t-stat, which is 0.55. So what you do now is you calculate what is the p-value corresponding to this particular t-test statistic. So you go to your t-table and you check what is the corresponding value for this 0.55, and you will see that is given by 0.2937. Since 0.2937 is greater than your level of significance, which is 0.1, you do not reject H0. So these are two approaches. Either you take the critical value approach or the p-value approach. That is depending on the given problem. So that is it for this section, hypothesis test for the mean. So in summary, we talked about hypothesis test for the mean in two areas where your population standard deviation is known and your population standard deviation is unknown. If your population standard deviation is known, you use your z-test statistic. If your population standard deviation is unknown or it is not given in the problem, you use your t-test statistic. You have two-tail test and one-tail test. Two-tail test is when you look at your alternative hypothesis. If it says not equal to some value, you know it's a two-tail test. In the one-tail test scenario, you have upper tail and lower tail test. How do you figure that out? You look at your alternative hypothesis, and when it comes to hypothesis testing, you have two approaches, either the critical value approach or the p-value approach. So that is it for hypothesis test for the mean. Now let's have a look at the hypothesis test for proportions. So in the case of hypothesis test for proportions, it involves categorical variables. That is an important point to keep in mind. And there are two possible outcomes. It possesses a characteristic of interest, or it does not possess a characteristic of interest. And the population proportion is given by the symbol pi. And the sample proportion is given by the symbol p, where simple p is defined by x over n, where x is the number in category of interest in sample divided by the sample size. Now when both x and n minus x are at least 5, p can be approximated by a normal distribution. So this condition is very important. When it comes to hypothesis testing for proportions, you have to check whether x and n minus x are at least 5. because only then can you say P can be approximated by a normal distribution with mean and standard deviation given by these two equations. So when you're given a population proportion hypothesis testing for population proportion problem, you must check these two conditions. And then under hypothesis testing, you have two areas, but we will be only discussing about one area. One is when these two conditions are not met. So this is not discussed in this particular chapter. But what we are discussing is only in the case where those two conditions are met, where your x and your n minus x are at least 5. So accordingly, in that case, you can your distribution of your sample population P is approximately normal. So the test statistic is given by Z, and that is given by this particular equation. Simple P is your sample proportion minus your population proportion divided by your sigma of P. Right. So you can also look at it in another way, where an equivalent form to the last slide, but in terms of the number in the category of interest X. So in the previous case, we looked at the sample proportion, but here you're looking at it in the category of interest of X. So in either way, you can solve this particular problem. But let's have a look at an example. So we are talking about hypothesis testing for proportions. So the given example is a marketing company claims that it receives responses from 8% of those surveyed. So to test this claim, a random sample of 500 were surveyed with 25 responses, and you're given the level of significance of 0.05. So what do you have to test first? You have to test those two conditions, x and n minus x. So your x would be, out of a random sample of 500, 20 was surveyed with 25 responses. So that is your x, that is your category of interest, 25x. And your n minus x would be, n is 500 minus 25 is 475. So both are greater than or equal to 5. So we have no issue. We can assume that the sample proportion is normally distributed. So you go ahead with writing down those steps, which is similar in this case as well. You write down your null hypothesis and the alternative hypothesis. Your hypothesis, now what you're testing is for the population proportion, whether it's equal to that 8%. So I've written it down as 0.08. And your alternative hypothesis is that value not being equal to 0.08. Your population proportion is not equal to 8%. So your level of significance, your sample size, and your sample proportion, you write those down, and then you write down your critical value. Since it is a Z test statistic that you're using for proportion, your critical value is plus or minus 1.96 for this given level of significance. And if you draw the graph, what you would get is this, where your mean is 0 and this is your shaded area, which is 0.025 and 0.025, because you divide alpha by 2. Since this is a two-tail test, how did I identify that? By looking at the alternative hypothesis. So you have your critical values minus and plus 1.96. Now you calculate your test statistic, which is minus 0.247. You simply substitute the values. Sample proportion is 0.05, population proportion is 0.08, and accordingly you get your Z stat as minus 2.47. So what is your decision? Your minus 0.247 is less than this 1.96, minus 1.96, which is in the rejection region or this shaded region. So your decision would be to reject H0 at alpha equals 0.05. So don't forget to mention that when you're rejecting when you're saying to reject H0, you have to mention at what level of significance are you rejecting it, at 0.05. And also, that is your decision. You have to write your conclusion as well. There is sufficient evidence to reject the company's claim of 8% response rate. So this is the critical value approach. The p-value approach would be, you calculate your p-value. And how do you do that? Now you know your critical value is at minus 0.247. You go to your table, your standardized normal distribution table, and you check where you would get this 2.47 value, you will see that the value you would get is 0.0068 from the table. And then you add these two values, because it's a two-tail test, so you add those two values, you get 0.0136. That is your p-value, and accordingly you compare that with your alpha. Since your p-value is less than alpha, you reject H0. Remember, if p-value is low, H0 must go. So p-value is less than alpha, so you reject your H0. So I have included a video here which contains some sample problems for population proportion. Go through this video, you will understand it a bit more than by looking at these problems given here in this particular video. So now we are done with this particular lesson structure. What we have to look at next is the next section, which is power of a hypothesis test. Now remember, this is an additional note, so I will not be testing this particular area, but it is good for you to keep an understanding about this particular section. So let's have a look at this power of a hypothesis test. So in order for you to get a better understanding, I have included a video here by JB Statistics. You can check the YouTube description down below. I have provided the link for this video as well. So when I'm talking about the power of a hypothesis test, it is basically the probability of correctly rejecting a false H0. That is this power of the test, power of the hypothesis test. The probability of correctly rejecting a false H0. So suppose we correctly reject H0 at mu greater than or equal to 52, when in fact the true mean is mu equals 50. Let's take that example. So how do you look at this graphically? So you have your graphs here like this. Why do I have two graphs? Because I'm talking about two areas where you correctly reject H0 where mu is greater than or equal to 52, when in fact the true mean is 50. So 52 is here, the graph pertaining to that is this red graph, and 50, that is the true mean, is given by this particular graph. So this shaded area and this shaded area, the shaded area in gray is your power of the test, which is given by 1 minus beta. Remember, I talked about beta and alpha in the second section of errors of hypothesis testing. So this red area is your level of significance alpha. So your rejection, you reject H0, which is mu greater than 52, greater than or equal to 52 in this area, if the value comes in this particular gray shaded area, and you do not reject your H0 if the value comes beyond this particular critical value over here. So the type 2 error, let's talk about that. So suppose we don't reject your null hypothesis when it is greater than or equal to 52, when in fact is the true mean is 50. So let's have a look at this graphically. So if that is the case, the type 2 error is given by this blue shaded area, right? So in that case, this green shaded area, that is a type 2 error, that is given by beta. So beta is actually the probability of your sample test statistic being greater than or equal to the particular cutoff mark if your population mean is 50. So let's have a look at a small example. Your sample size is 64, your population standard deviation is 6, and your level of significance is 0.05. So how do you calculate your cutoff mark? That is x bar at that particular level of significance. That is mu minus z alpha times sigma over root n. So you get 50.766. Now how do you put that into the particular graph we looked at before? So 50.766 is this value over here, the cutoff mark. So how do you calculate beta? It is the probability of this x bar greater than 50.766 if mu is 50. So how do we calculate that? We look at the Z distribution and you use your Z statistic. So you know that the cutoff mark is 50.766 minus your population mean is 50 divided by your sigma is 6 divided by square root of your sample size. So the probability value you would get is 0.1539. So the green shaded area is 0.1539. So the power of the test statistic is given by 1 minus beta. So that is 1 minus 0.1539 is 0.8461. So that is the probability of correctly rejecting a false H0. So the probability of correctly rejecting H0, a false H0 is 0.8641. So the power of the test, which is 1 minus beta. What are the conclusions? It is a one-tail test is more powerful than a two-tail test. An increase in alpha results in an increase in the power of the test. An increase in the sample size also results in an increase in the power of the test. So just go through this again and you will see how these things are calculated. The power of the hypothesis test is also an important section to look at. Just have a basic understanding of how you calculate it. So that is it for this particular chapter. So the chapter summary, we talked about Z test, sigma known and sigma unknown, the t test case for mean, and the Z test for the proportion. Critical value approach we talked about one tail and two tail test, and we talked about power of a hypothesis test. This is what we looked at in the chapter summary. Make sure you go through this reference book, that there are many problems given in this reference book. I have also included this explanation of the video in one of the PowerPoints. Remember, I have included two PowerPoints in your LMS Moodle, one in which you have these videos and the other one in which you do not have these videos. In the one in which you have videos, I have included this explanation. So that is it. Thank you very much. I hope you have a good day. Dream big and start small. Thank you very much.